Hello there, I am Krebs, and I spent my life figuring out how your cells turn food into energy. And trust me, it's not as simple as just eating and poof, energy. No, it's a beautiful, intricate cycle. But here's the funny thing, you will have to relearn this at least 3 times in your life. That was a lie, by the way. First in high school, and then in college, and again when you realize you forgot it before your big exam. Yup, a lie. Because the real cycle is learning and forgetting Krebs cycle all over again. It happens to everyone, even biochemists. Well, this time, it's the truth. So let's make it count, shall we? Now, before we dive into my famous Krebs cycle, we have to prepare our fuel. That means starting with something called the pyruvate oxidation. So, after you eat, glucose is broken down in a process called glycolysis, which happens outside the mitochondria. This gives us 2 molecules of pyruvate, but pyruvate can just waltz into the Krebs cycle. No. It needs a makeover first, and that's where pyruvate oxidation comes in. Here is the transformation process, the carboxylation. Each pyruvate loses 1 carbon of CO2 or carbon dioxide. Yes, you are literally exhaling part of your lunch right now. Oxidation. Electrons are stolen by NAD+, literally forming NADH, which will be super useful later on. The remaining acetyl group gets attached to coenzyme A or CoA, forming acetyl-CoA, or golden ticket into the Krebs cycle. This happens twice per glucose molecule. We end up with 2 acetyl-CoA ready for the Krebs cycle, 2 NADH which will power ATP production later, and 2 carbon dioxides which will breathe out like a pro. Alright, now that our fuel is ready, let's start up our engine. The Krebs cycle, my pride and joy, also known as the citric acid cycle. It's basically a biochemical conveyor belt that keeps your cell running. Here's what happens step by step. First, acetyl-CoA, 2C meets oxaloacetate 4C. They combine to form a C-carbon molecule citrate. Yes, the same thing in citrus fruits, but please don't try to power your body with lemonade. Second, the carboxylation, which will happen twice. 2 CO2 or carbon dioxide molecules are removed and released. More exhaled lunch? Good job! Energy extraction. NAD+ and FAD grab electrons, forming 3 NADH and 1 FADH2 per cycle. Think of this as rechargeable energy batteries. ATP production. So, 1 molecule of ATP or GTP is made per cycle. The cycle resets, waiting for the next acetyl-CoA to revive. Since the cycle runs twice per glucose, here's what we get overall. 6 NADH, your rechargeable energy pack, 2 FADH2, more electrons, more ATP later. 2 ATP, we have more useful energy, and 4 carbon dioxide, which you will exhale again, like food. And guess what? All of this is happening inside every single one of your cells, non-stop, 24/7, even when you're sleeping, even when you're cramming for an exam about, this exact topic. So why should you care? Well, without the Krebs cycle, your cells would be out of fuel. You'd feel as lifeless as someone with a 1% battery. Or even 0, honestly, like a dead battery. NADH and FADH2 fuel the electron transport chain, where the real ATP jackpot happens. It's basically a metabolic hub. Your body can convert fats and proteins into energy through the cycle too. And let's be real, it's a classic. If you're studying biochemistry, this is the cycle to know. Next up, the electron transport chain, where we cash in all this NADH and FADH2 for a serious ATP payout. But that's the lesson for the next time. Goodbye! Oh, it's locked. Haha, bye. Bye!